Hey everybody, in this video we are going to apply the difference quotient to the function f of x equals 1 over x. This is the fourth example, so they're slowly getting a little bit more intricate and requiring a good variety of algebraic techniques and strategies to get us to the position we need to be in to eventually take this difference quotient and fully dive into the limit definition of a derivative, which is the foundation of a lot of calculus. So let's get started. The first thing I'm going to do is I'm going to write out what I'm finding. I'm finding f of x plus h. So I'm going to, everywhere I have an x in this given function, I'm going to substitute x plus h. So really I'm just left with 1 over x plus h. So everywhere I had an x, I filled in x plus h. Now there's really not much I can do at this moment with this equation the way it is. It's not like some of the other ones in the playlist where I could take it a little bit further. So I am just going to rewrite it for my organizing, but f of x plus h is, in conclusion, 1 over x plus h. That's the most we can do. So I'm just going to reiterate that right here. F of x plus h is equal to 1 over x plus h. And we're going to end up applying that to this difference quotient right over here. And in that difference quotient, in the difference part of it, we have f of x, and the f of x is really just the 1 over x, so that's going to have to go in there. What we're going to see is we're going to have some compound fractions, and we're going to clear them up and organize everything using what I like to call my hamburger method. So let's write out what we're finding first, which I think is a very good habit to have, especially in calc, because it gets really confusing. Are you doing the original function, the first derivative, the second derivative? What is this that you're working with? And you want to make sure, you stay organized. So we have 1 over x plus h minus 1 over x all over h. So just to point out, that right there is the f of x. Then this right here, f of x plus h, is that right there. Now, as much as some people may want this to be done, it's not done. Nobody likes a compound fraction or complex fraction, so we're going to multiply on top and bottom by the LCD. So the lowest common denominator, I'm going to multiply on top and bottom by. And we're allowed to do that because anything over itself is 1, and we're totally allowed to multiply anything by 1. Now, what would the lowest common denominator be of all three of these components or parts? That would be x times x plus h. It's the product of these two distinct denominators, x times x plus h. Now, when I multiply this to both the numerator and denominator, what happens? Well, in the numerator, it's going to distribute, and things are going to work out pretty nicely. When I multiply this by that first fraction right over there, what ends up happening is the x plus h's cross out, because this is really, you're not going to write this is ridiculous, but over 1. So that x plus h is going to be on top, that one's on bottom. They're going to cross out, and that's what we want. We want to get rid of all of these layered fractions. So after the x plus h crosses out, I'm just left with x. And then I have my minus sign. So there's the minus sign, there's the minus sign. So I've got my bold minus sign, okay? Now I'm going to distribute the same exact thing to 1 over x. And in the same way, the x's are going to cross out, and I'm going to be left with x plus h. And since that's more than one term, I'm going to make sure I put parentheses around it. So again, I remember to properly distribute. And as for the denominator, that h is the devil, and we don't want to distribute the devil into everything else. We do not want it to mix in with the rest of the bottom. That h, we're going to cross it out. That's going to be part of the end goal. We're going to get rid of that guy right over there. Okay. Lost this parenthesis. There we go. So again, it is the devil. Okay. That h, he is problematic. We got to get rid of him. He's got to go, and we'll make that happen in a moment. Now, in my numerator. I'll end up with x minus h. all over h times x plus h. Okay, looking good. We're doing great. Now, on the numerator here, the first thing that's going to happen is x minus x turns to 0. So that's gone. The next thing is negative h over h is going to leave us with, in the numerator, negative 1. And we're very happy because we got rid of that devilish h on bottom. And again, to understand why we got rid of it, go back and watch the introduction. Okay? X times x plus h. Now, I know you said, oh, but h is the devil. Why are we leaving this h? This h is less problematic because part of what's going to be involved is we're going to fill in 0 for h. If we filled in 0 for h in that situation or that situation, I would get a 0 in my denominator because it's being multiplied, and I would get undefined, and that's not what we want. And we would actually get 0 over 0, which shows us that we can divide or reduce because that is what we call indeterminate form. So here, as for what the question's asking us to find, we are technically done. All right, f of x plus h minus f of x all over h, the difference quotient, the answer is indeed that right there. However, if we wanted to take it just a hair further, right, in calculus, you will fill in that 0 for the h, and I'll be left with negative 1 over x times x, which is x squared. And that, my friends, would be, with limit notation out front, would be what we call the derivative. So the derivative of 1 over x is negative 1 over x squared. And that was how we could do it algebraically, in a sense, using the limit definition of a derivative, using the difference quotient. However, I did not truly do it with the limit written out front. That was just a little bonus extra feature at the end. We'll get more into that later in honors pre-calculus. Hopefully that was helpful. Hopefully you feel smart. Thumbs up. Thanks a lot. Click through for what you need next, and bye for now. Adios.